Hey, how's everyone doing? Can everyone hear me nice and well right now? Are we all hearing me now? We updated the computer and we did some stuff. Sorry, we moved around some stuff and we fixed it all. Yay, I hear audio. So, so good to have everyone. I've sent the new link out. This is a public video also, so who knows what's going to happen? You never know what's going to happen live. So we sent out the link. Did everyone see the link? We should have the link sent out. I also changed it and everything. It looked like, I don't know, I updated the computer. I probably should have never done that. Do update your computers. But there was a bunch of updates installed yesterday, and then we moved the studio around a little bit. So something happened, but we got it fixed. So did everyone get the link? Did everyone had the link to it? So we were able to fix that in about 7 minutes, but we reset the computer like 4 times, and we jiggled all the wires. That's how you fix it. You just make sure, and it's really good. I'm so glad I have people to help me because we fixed it and figured it out. So people have the link. We got everything figured out, and I probably think it was probably my fault. It's probably me. No, I shouldn't have updated the computer. Brian, we need to just because that, and if you do have that, talk to us. We will figure out a reasonable way to handle that. So please email me if that is a concern to you right there. And I do agree that you can have that concern. That is reasonable. So email me, and we will work on that. We're also sending an announcement later tonight. And we do ask this. Let's start with that. If you are feeling sick, or have major concerns, please, we will work something out. So if you are feeling sick, especially if you're coughing, if you're short of breath, showing a lot of the symptoms, then please do not come to the exam. We will work everything out. If you feel like you're immunocompromised, then there's reasonable concerns. We will work something out, especially if you are feeling sick and coughing. We ask that you do not come to the exam, and we will work something out with you. We will have a very fair way of working with you. We're going to work with all students and be fair and understanding to making this work. And so we're doing everything we can to help with this situation, and great concerns and great questions there to start class. So please email us, and I'll be sending an email announcement in a little bit. Everything's been so busy, especially with all of this right here. And I do want to say this, we are definitely talking about these things. We're having the conversations, and we're making sure we take all the steps that are needed. And that's why this email you'll see later tonight is making it very explicit that if you are feeling sick or exhibiting symptoms, please do not come to the exam. We realize you're like, it's an exam, I got to go to the exam. We will work with you. We will make everything, you'll get to do the exam in a fair way, and we want you to think it's fair. We don't want to say it'll be fair. We will be very fair to everyone who takes the exam. If you have reasonable belief that you are sick, if you didn't have time to go to the doctor, if you have reasonable belief, we will work with you. And we don't want people to, we want everyone to use their best judgment, and we trust your best judgment. We will send it out. This is just from Stat 201. This is just Stat 201 speaking on behalf of Stat 201, but I know everyone has been working hard on this and making sure we take Zach. I know everyone's been working really hard on this and making sure we do. At 1:55? Today I teach. Today is teaching. Tomorrow, so Casey, today I teach. Is that and check it out. The office hours are posted. I can probably show those really quick here. I'll show those again. Tomorrow I'll be doing office hours. Let me show the office hours. Here we go. That should be showing my office hours there. So today's office hours, I was there from 10 a.m. to 12:30, and tomorrow I'll be there a little bit longer. I'm also going to do a bunch of Stat Lab stuff tomorrow, so I'm going to move around. We're going to do the Kahoot tomorrow, but please email us if you have any concerns. I already got my test back, but didn't go over it with you. Yep, you can still do that. You can definitely still do that. Swing by and just be like, hey, Brian, I want to talk about this. And usually I'll sit down with people and work through the whole test with them to make sure. If you have reasonable belief, we'll take reasonable belief. We want everyone to feel safe, and we want everyone to feel that we are, that's what we want. It's not just that we want you to feel that. We actually do care about you staying well and healthy, and so we take the reasonable belief route. And we definitely want anyone who's immunocompromised or people who feel sick. So fun stuff. All the fun topics. Will we have class on Thursday? Yes, we will. Yep, we'll have class. We're meeting right here and we're reviewing. We'll start reviewing in a second right here and we will continue on. But I will say we are definitely, as a university, taking every step and being aware of everything. I was not in it, but I will say, as people are pointing out, this is something we've been talking about and something we are very cognizant of. And I believe the university is taking all the best steps and being very, very, I'm seeing so many things. Oh my gosh, fun things. ArcGIS, good things. Is there any way we could be more spread out in A and B? We're going to try to do as best we can on that. That is a really good, we're going to try to do as best we can. So all of that good stuff right there. I disagree with that. I disagree. Well, you guys want to do some topics here? Let's do some topics. But I say this, and I really say this, I promise you, I know so many university officials who are concerned about it and concerned about making the right decisions. And that's what they're working on right there. Oh, really? Oh my gosh. Well, I promise you, and I promise from being on the inside that I've had many conversations. I have had many, like, what's the best steps and what plans should we have? And that's why we started a talk this weekend about the email, which now we have crafted, which we will be putting out. So let's hop into review. You guys and gals ready to review? So we are going to start reviewing right here, and let's do it now. So yay, let's do some review. Awesome. So let's do it. What topic do people have the most question on regarding this test? And we'll go a little bit longer today. Sorry for all the little tech troubles there. It happens when we change things up, and so we were able to fix it pretty easily. Can we do a confidence roll? Of course we can. Let's do some confidence rolls right here. Let's start with a confidence roll question. And this is what you can do to get an extra sticker, is you can start by going here and writing your own question. So it is kind of cumulative, but not really. So we want to start with a confidence roll question, and let's check it out. So in a confidence roll question, we need to start with sampling. So let's think about how we would sample individuals. We go out and talk to 1,000 random people from Tennessee. There we go. From these individuals, 650 of them believe Tennessee will win a bowl game next year. Construct, and we will have these formulas for this, construct a 95% confidence interval using a z-score of 1.96. Construct a 95% confidence interval using a z-score of 1.96. Now, you will be given the z-scores. We don't expect you to memorize z-scores, but you should be able to go through this question. And the first thing I'm going to do, and you should do this too, is you should identify the notation. Zach already started with 1,000 points right there. Nice, Zach. We go right here, and we get 1,000. And what is 1,000? 1,000 is n, as Zach puts in the chat. Be following along and be working these problems. 1,000 is n. Then what do we see right here? We see 650. And what is 650? I think they've already figured it out. I need to know in the chat, what is 650? 1,000 points, everyone answering. 650 is x. Carlos, you are doing an amazing job right there. 650 is x. And so x over n is p hat. A lot of people are figuring that out right now. And then what is the z-score? Well, that's the z-score. The z-score gives us the percent confidence. It's important as we work this problem, we identify all the notation and we think about how this is talked about. We can go down here to the bottom now and we can do x over n equals p hat. X over n equals p hat. So this is the sample proportion right here. So when we solve this problem right here, we'd get 650 over 1,000 is equal to 0.65. And this is going to be the sample proportion right there. Do we get points for being early? Yes. You know what? For all the technical goofs and everything today, all the craziness, we're offering 50,000 points. Be here the whole time, 50,000 points, big points for being here today, all that great stuff, and I really appreciate it. The confidence interval one's not bad, and it's going to help you out with the third exam. That's a pretty good video, Reagan, right there. That's a pretty good video. It'll cover extra things, but it'll get you prepared for exam 3 also. So you will be ahead of the game if you watch the confidence interval, one. So check out the confidence interval video, and if you're looking for these, that's a great video that gets you prepared for the third exam. Can you explain how you know when you are looking at p hat or just p? So a big question right here is what's the difference between p, and so Caleb, 1,000 much right there, p and p hat, we have p and p hat. P and p hat are the difference between the true proportion and the sample proportion. So the sample proportion is going to be our estimate of the true proportion. P hat is the estimate of the true proportion. So in this question, we have p hat, which is being used to estimate the true proportion. So, and p is kind of the true number. P hat is our guess of the truth. So think about this. What would you say to me if you're just talking to me in words? Just talk to me as a sentence, not as a statistician, but just use a sentence and say, Brian, it looks to me about what percent of Tennesseans believe that we will win a bowl game. And I'm going to move the Kahoot to tomorrow. So the Kahoot will be tomorrow. I'm going to move that, and I'll send some email announcement reminders. Sorry for the confusion on that. Like, what were the keywords to be looked at? So with this question right here, we would have that 65% of Tennesseans believe that we will win a bowl game. From our what, though? Yes, about 65. And is this a p hat? It is. And the Kahoot will be at 5 tomorrow. It'll be after the review tomorrow. I think so. I'll send out some reminders about that. Sorry, Ashton, for the little bit of confusion on that. We've been moving things around so much that my brain's like, wait a minute. I'll send out some reminders, and it'll be posted to the YouTube channel. You'll see a reminder tonight for it. How do we get the z-score if it's not given to us? You won't have to find it. On the test, we will explicitly say this is the z-score. So when you look at this right here, what does this p hat mean? And don't worry, it'll be recorded. There you go. That's going to be, well, we're already there. We're already online. So fun stuff. So with this right here, we go out and talk to 1,000 1,000 Tennesseans, and we have 650 of them believe that Tennessee will win a bowl game. So, I wrote 100. Oh no, 100,000 points correcting me. Thank you so much. So right here we have that we need to make this interval. So let's write the equation. I agree, Rex. We have here that p hat plus or minus z star. So here's what I want you to do. I want you to take out a sheet of paper if you've not. Take out a sheet of paper, and I want you to write this equation and start solving it. I want you to write this equation and start solving it. So go ahead right now and start solving your equation. So who has this equation written out right here? We need to figure out this equation. So we have here 1.96, and then we have p hat. Nice job. We're going to write here plus or minus. We're going to put here 0.65, and then we're going to go here. How do we find q hat? How do we find q hat? Exactly. And then n is going to be 1,000. There we go. We have p hat, q hat over n, square root. And so we have the z-score right there also. So this is going to be our interval right here. Make sure you're writing this down with me. This is a great way to solve an interval. Does anyone know what our interval is? Who has the interval? Who has solved for this interval? All you need to do is solve this equation. Be very careful. It's a little bit tricky sometimes. Who has the interval? I think we have Sneh, great job. We have here, I'm going to have to go a little bit this way. And then we have 0.67. Now it looks like that rounds up, so I'm going to go ahead and round that one up. And I'll tell you why I'm doing this. The reason why I did this, and hopefully I'm out of the way a little bit there. Let me make it look a little bit nicer. So we have here 62 to 68%. With 62 to 68% of our interval, we are saying I am, and I want to see it in the chat. What does the star next to the Z mean? It means we get to pick it right here. So we can pick what this Z is. So we'd say I am 95% confident that the true proportion of Tennesseans who believe that we will win a bowl game is contained in the interval 62 to 68%. I am 95% confident the true proportion of Tennesseans who think we will win a bowl game is contained in the interval 62 to 68%. I think, Kaylee, excellent work right there. The true proportion. Be writing this in the chat for 10,000 points right now. I want to see it because we have right here an interpretation for a 95% confidence interval. And this is what we need to work on. We need to make sure we can write that out. And by writing it out right now, you're getting practice. So we just did a confidence interval for the true proportion. And if you're seeing how to write in the chat, make sure you're doing it. And you will have learned how to write. I am blank percent confident that the true blank is contained in the interval blank to blank. Now, what do we notice here? We made a confidence interval, but we didn't check the conditions. Who here can help us out and check the 3 conditions for a 95% confidence interval? Or any confidence interval in that regard. What is condition 1? Who knows my condition 1? Who's got condition 1 for me? What is condition 1? It can be 10%, but I like to say random. And random is yes. Why? Why on the test would you put that this is random? Because it came from a random sample. So this is random because it came from a random sample. Condition 2, what's condition 2? Condition 2 would be what? What is condition 2 right here? Less than 10%. So is 1,000 Tennesseans less than 10% of all Tennesseans? We have to ask ourselves these questions when we do the 10%. And how would we write this on the test? I'm throwing in, you know what time it is. Everyone knows what time it is when I start to say that. It's random time. It's 100,000 points if you can tell me in a full sentence why the 10% condition is met. You have to do a full sentence and you have to tell me why the 10% condition is met. I want to see it like it's a test question. Like, what would you write on the test? And by writing it out right now or reading what other people write and writing it down by hand, it'll get you lots of practice of doing it. Why is the 10% condition met? What does it mean? You have to know what it means. It means we sample less than 10% of the populations. I think, Zach, I'm giving you 50,000 because I think Madeline got the full right there. Madeline, and we're going to make Madeline a mod right here. Madeline, you've earned mod status, and you got the question correct. Zach also got 50,000, but Madeline was first right there. She said that 1,000 Tennesseans is less than 10% of the population of all Tennesseans. That is very, very much correct. So does that make sense right there? We can assume that there are more than, and also that kind of works there too, Mackenzie. I like that. I think Mackenzie, the first person to say that, so I'm throwing Mackenzie 100,000 points also. Zach, why not? You were first, so 100,000. I like when people answer first. You're thinking, you're trying to be quick. Great job. But 1,000 is less than 10% of all Tennesseans. The 10% condition states that we need to sample less than 10% of the population. It sounds weird because you would think that you'd want more. You do want more when you sample, but it's just the way the mathematics work. The mathematics are that we want to sample less than 10%. So the last condition right here is the what condition. Now we do pause. No one said pause yet, but we pause before doing the last condition because we want to think about it. Pause, Reagan, 10,000 points, and Connor, 10,000 points for success failure. So it is success failure, and we pause because oftentimes people just write down everything and they just memorize it and they're like, I don't know why. It's success failure because it's categorical. When it's categorical, I'll send out the video link to that, or Lauren, email me and I'll send you a video link to it where we go through it. And that one is from chapter 13, part 1. Chapter 13, part 1. So, and I'll send you a video link where we work through it. It's at the March 3rd video. It's a week ago we did it. So check out the end of March 3rd. If you can't find it, email me and I'll send it to you. But I'll be replying to a lot of emails today. So yay, fun. So what were we saying? Success failure. Success failure is that we need at least 10 successes and at least 10 failures. So we need to have at least 10 successes and at least 10 failures. Does that make sense, everybody? At least 10 successes and at least 10 failures. So how many successes were there? How many successes were there and how many failures? What would you write on the test? Once again, it's time for everyone's favorite meme. We're going here and we're going back to random. I want to hear a full sentence. I got to see that full sentence in the chat. I got to see a full sentence like you put it on the test. So let's see the full sentence right here. Who's got the best full sentence? You got to give me a full sentence like it's the test. Now, I do see right answers. They're kind of right. I want to see a full sentence. I see some decent stuff. I know. I don't think it will either. It's so happy. Close. I'm seeing some good answers. Probably these will probably get full credit. I want to say this. I see it. Kaylee right here. Kaylee, there are 650 successes and 350 failures, which are both more than 10. Yes, that's it right there. And I'm throwing 50,000 for everyone who answered. We're just going big points today, keeping everyone fun, keeping everyone happy. If you answered and you didn't get, you get 50, but Kaylee gets 100,000. So if you notice, we have, and I'm going to be adding up all the points over spring break. Ooh, I can't wait to see what everyone's at. That's going to be some fun. So look for your extra credit to be added up and posted to Canvas. But if you look at what people are answering, there were 650 successes, and look at how we can figure out how many failures there are. Does everyone understand that either people will say we will win a bowl game, which is the right answer, or people will say we won't win a bowl game, which they can just leave, they can get out. Sorry. But we have 650 yeses and 350 nos. That's what success failure is doing. It's saying we have at least 10 yeses and at least 10 nos. That's what a success failure is. It's yeses and nos, basically, and we have at least 10 of both. That's it. Nice job, Julio, in the chat. So awesome stuff. We have now checked all the conditions. But let's mention something important right here. By checking all the conditions, we're actually seeing if the distribution is what shaped. Now think about the equation we just wrote. By writing the following, hint, hint, right there, hint, what are we assuming about this distribution by especially using this? What does that assume? Oh my gosh, you guys are awesome. Everyone's saying normal in the chat. I love the chat. You know, there are so many people I miss after this semester by just how they chat. And I'm glad you guys have fun. I love the stream. I'm hoping you guys like this too. Sorry for the tech difficulties earlier. Don't update your computer. I mean, do if you want. But I truthfully think, I hope Jason sees this. I think it was my fault. It was like, you have a bunch of updates. And I was like, oh, we should update the computer. And then I did, and then all of a sudden the mic was being weird. What do the three conditions test for? The three conditions make sure that it is appropriate to use a confidence interval. So the three conditions we just did tell us that a confidence interval is appropriate, or more specifically, a lot of times we're using the normal curve right here, and this uses the normal curve. So is it appropriate to use the normal curve or these confidence interval formulas? And the answer is yes. It is appropriate to use the normal curve and the confidence interval formulas because we meet all three conditions. We also did this previously. New window right there. We did this previously when we were doing the sampling distribution. This is another tough chapter that people often have trouble with. The mean for the sampling distribution of p hat is equal to p, and the standard deviation for the sampling distribution of p hat is equal to p times q over n square root. Now, when you draw out your distribution, if you meet all conditions, you basically have the central limit theorem stating that the distribution will be normally distributed. And this is what we get. We get right here, the center of this distribution will be P, and then we will go up and down these amounts right here. So this amount right here is how much we are going up and down each amount. So I guess we could put that thing around it, but this is the amount we go up and down. And what does a question like this look like? This is where I want you to practice, and I want you to be able to write out a question. You really know what's going on if you have a question written out that you could solve for this. In this question, look at what you have to give someone. What would you have to give someone? Look at what's written here to solve a question like this. There's very little you have to give to solve this question. Who can tell me what you would have to give to come up with a sampling distribution question? How would we know the shape? So if the conditions are met, the shape is normal. So it'll be normal with the mean and the standard deviation. People have asked me this. They're like, wait a minute, there's some questions on the homework that say this. And I've kind of alluded to it, and I've like explicitly said it, or implicitly said it, not explicitly. But Yes, we're going to look at that. Definitely, and everyone read that email. I'm going to read it after class, and so that might, we'll see. I will give all the updates. We're going to follow every university standard. So, Casey, great stuff right there. So we're going to follow all the university standards. Whatever they say, we're going to do. And as people have said, we're online, so we're good to go. So we're lucky because luckily it doesn't do. Thank you, Zach. Zach, you're awesome. So what sample size? Yes. James, that is a great question from the homework. And I think you might, I'll do that here in a second. So, and as Julio points out, and we'll switch to James's question here in a second, and I'll show you guys a trick. You guys want to see a trick to solve the homework questions? I'll help you out big time here. We're going to do some big time help right here for the homework due tomorrow night. You get 0.1, you get 0.1 points, Zach. So this question right here, I know, right? What if that happens? That'll be interesting. Right here, you'll notice that we have P and we have P, Q, and N. Now, why does someone not have to give you Q? Why does someone not have to give you Q? Explain to me why is there no Q? Why do we not need Q right here? Why would someone not need to tell you Q? They just need to tell you P. It's a good theory thing to know. Boom, Abby gets 10,000 in the chat. We get right here that Q is 1 minus P, so we know exactly what's going on. Q is 1 minus P. We got it. We know what P and Q are because we got it. So with this right here, let's take a look. And this question could be written the following way. So what we have is, suppose that 80% of UT students think Taco Bell is the best fine dining that exists. If you went out and spoke to 200 students, would it be odd that only 140 of them, so, and we should say random, so spoke to 200 random students, would it be odd? So we've basically written a question right here. We've written everything right here that we need to solve this question. Now, be careful. What you have to realize is that this is 13.1, not 13.2. In this question, what are you given to start? This is what? This is changed now. There's a hint on the screen. So what is this that we've given you to start? That is P, because we're saying this is the truth. Now, you can solve for P hat. There's X and there's N. So, and that is the mean of the distribution. Dylan is right. That'll be the center of the distribution. It is the true proportion. But I want everyone to say this, 10,000 points if you say it. We're throwing out huge points. If 80% of UT students think Taco Bell is the best fine dining there is, and you took a sample, what would you expect to see? Like, you talked to 200 students, what percent of UT students in that sample would you expect to say Taco Bell is the best fine dining there is? Which is what I think. I just like Taco Bell. 80%. You're just saying if 80% of people believe this, and if I talk to people, I'd expect to see 80%. So you know what goes right here at the center? Right here at the center of the curve is, you guessed it, 80%. It's like if you threw a dart at this board and it goes boop and lands right there, that's kind of the most likely spot for it to hit. And it would be unlikely that you would land over here because that's 3 standard deviations below. So we're going to need to find out how unlikely our P hat was. Now, who knows for 10,000 points in the chat what this P hat is? What is the P hat that we have right here? What is P hat? Remember the formula for P hat is X over N equals P hat. So what is the formula for P hat? You are correct. It is 140 over 200, 10,000 points in the chat. It is 0.70. Now, we need to know, we've written all this out before. I'm going to scroll down a little bit and zoom out. There we go. We need to know the mu P hat, which is the center of the curve, equals P, which we just wrote right there. We need to know the standard deviation of P hat, which is P times Q over N square root. And we're going to solve that. Q, what is Q in the chat? Let everyone know the P and Q game. I love the chat. Oh, people already got it? Who got that? 10,000 points right there, James. Nice job, James. So we're going to do P times Q. 10,000 people saying Q in the chat because it's just 1 minus P is Q. Always know that, quick and easy. But don't worry, if you don't know it, ask it in the chat. Oh, it's going to be, you're right. I think it is going to be very odd. Nice job, Snay. Excellent work, 10,000 points on that answer. Please tell me if I type something wrong. P times Q over N square root. Oh my God, what did I do? P times Q. It's one of those fun days. It's like, watch what happens live. You'll never know. Because I don't even know. Oh, I inversed it. That's the inverse button. So P times Q over N square root. Great question, Neely, for 1,000 points right there. How do you find Q? If P is 0.8, Q is 0.2. If P is 0.6, Q is 0.4. If P is 0.1, Q is 0.9. So whatever P and Q are, they must add up to 1. And as Abby points out for 1,000 points also, why not? Both of you get 10,000. I've been saying 10,000 a day. It's 1 minus P. So you just subtract from 1 P. So if P is 0.8, Q is 0.2. So just they are complements of each other. So that's a great question right there. And thank you for the question. I want everyone to ask every question they have. So we're just going to round this for the moment. I'm going to do a nice round on this. So let's go ahead and round this to 0.03. That's a very generous roundup. So then this would be 0.77. This would be 0.74. This would be 0.71. And then we landed all the way down here. Look at that. Do a little other space pen color. You can do it multiple times to get different space pens on it. So we are all the way... We are all the way off the side right there. This is very unusual. It might tell us that something's wrong. Why are people not liking Taco Bell as we thought they would? So we see right here that way fewer like Taco Bell than we would have expected in our sample. So we can figure out the z-score on this. Now remember our z-score formula is, we would have here observed, which is this. And let's put a little line right here. Put a red line. This is our z-score. We have observed minus expected over standard deviation. There is no hat on that P. And am I covering? I'm not covering it. P times Q over N square root. And so we're going to plug in the numbers right here. I observed 70%. So if I observe 70%, then I subtract the 80%. I'm doing this formula. I'm solving this formula right now, right here. So whatever I get, you're watching me plug it in as we solve it. I might answer the space pen formula a second here. So this is P hat minus P, and then we divide by, and that is where it went. Do you notice that I landed 3.5 standard deviations, and you will get formulas like this right here. So you notice I land 3.5 standard deviations below the mean. That's exactly right there. So that's what that means, is it's very unusual. So Zach, do you get it? The question in the chat Zach asked, and everyone's saying it, Machen's saying it. Can you go over the problems that involve higher confidence making curves wider? Yes. And let me mention this. So that's an example question we just did right here. Great example stuff right here. That is unusual. We'd say that is very, very unusual. So we'd be like, that's not likely. So we'd be like, that was a weird sample. I'm going to do some mathematics. This will be a huge help for your homework assignments that ask you to do algebra ones. So that highlighted equation is how you found where the purple mark is. That is correct. Abby, nice job. Go back. Yes. Abby, great question. This highlighted equation solved for the z-score. So this solves right here for a z-score. And the z-score is how many standard deviations something is away. So if you notice, we're at 70. This is where the p hat was. And p hat was equal to 0.70. And that is 3.5 standard deviations. You will get these formulas. And does this make sense right here? That we found out that we observed something, and look at the formula real quick. The formula is what we saw in our sample minus what we expect, which is the center of the curve, divided by the standard deviation, which tells us how many standard deviations something is away. So the p hat is found by, that is correct, p hat is x over n, and p hat is defined as the sample proportion. So, and great job, Kendrick 10,000, Colby 10,000. I appreciate all the questions and answers in chat. I love it when everyone's helping everyone out. Great chat today. How many did I'm so sorry for those errors at the start. How many people do we have watching now? Did I scare it? 126? That's all right. It's not one of our most watched streams, but I'll take it, especially with the errors I did. So with this right here, does this make some more sense? I know people want me to go back. Does everyone understand what's going on here with this formula and how we figured out all of this right here? 131, way better. I like it. So I think we're good on this question. I'm going to give some help for the homework right now for people. There's been some hard questions people are stuck on. And so there's some questions that ask you, if it is 2 standard deviations away from the center, then it's considered odd, right? Yeah, 2 is kind of odd and 3 is really odd. 2 is kind of odd and 3 is really odd. So you guys are awesome in the chat. Watch this. You get problems on my Pearson that asks you for the margin of error, or it gives you the margin of error, and then it gives you like the z-score. And these are confidence interval questions where it says, what sample size would we need for a certain margin of error? So it'll say like, okay, we want a margin of error of like, we'll do over like here on the side. It says like, you want the margin of error to be 0.02 and you want a 95% confidence interval. And then you want also, maybe if it tells you the percentages, it's like something like 80% and 20%. So that's p hat and that's q hat. And then it says solve for n. So if you notice, some of you may have seen questions like this where it says like, you went out and 20 out of 100 people responded this way. You want to make a 95% confidence interval, which tells you the z-score. When you know the confidence, you know the z-score. So please remember, someone asked earlier, what does the star mean that we usually put on this? The star means you get to pick it. It can be any value which corresponds to a certain confidence interval. And the decision tree of the project is a huge help for that. With the hat, and sometimes not with the hat, is there a difference between the two? Elizabeth, great question. This is for a confidence interval, and the other one is for the sampling distribution. So when you make a confidence interval, you make a confidence interval from the sample to estimate the truth. And when you have the truth, which we saw previously in this question, I just want to highlight these differences that Elizabeth's asking about. This one is where we have P, and we're asking what might happen in a sample. But the previous question right here, we said we took a sample and we want to know the truth for the population. So this question right here says we take a sample and here's what we observe in our sample. Now we want to estimate the truth for the population. This question says we know the truth for the population, or it's just to suppose as though this is the truth. So when we know the truth, we will use P. So whenever it says something like 80% of hot water heaters last 10 years, that means that's the truth. Then it says we took a sample of 100 hot water heaters and 60 of them last. Well, then 60% would be p hat because a sample always has a sample size. Does that help right there, Elizabeth? That the sample always has a sample size and p is always the truth. We'll do that next. Here's Zach. And then there's some, I'm going to answer Sneha's question next. We're going to talk about this one real quick here. And then I'm going to answer that question next. And then we'll do decision trees. Great stuff in the chat. Okay. So for this one right here, watch the algebra. What you can do is you can take and divide this side, the margin of error, by the z-score, and then you get this. Then you can take, and I'm going to delete this, and to remove the square root, you can square this. So now you're almost solved. We just need to flip it now. So we'll go right here, and we'll flip both sides. You can do this. You can just flip both sides of it. And let's do this. Let's go z, m-e, and then we go here, and then we go n on top, and p hat, q hat, and we're almost done. All we need to do now, we're so close. That's another solve right there. We've basically solved it. We're just going to times both sides by p hat, q hat, and then it'd be inside of here, z, me, and squared equals n. And so for all those questions that are asking you to solve, so the reason for flipping it, I'll explain. It's like saying if you have 1/4 equals 2, I can't even think right now, 2/8. So 1/4 equals 2/8 is the same thing if you flip it as 8/2 equals 4/1. So mathematically you can flip stuff You can do this with it. Does that make sense? It's just a mathematical thing to do, solving it algebraically. So now you can just plug in the numbers there and it'll solve. Why do we flip it? We want to solve for n. So I'm getting n to be where we're just solving for n. And so I just flip both sides of it, and then we can solve for n, because right now the question is, what does ME stand for? Margin of error. So Elizabeth, another 10,000 points, and also Haley for asking. And there's lots of questions in the chat. I saw pretty much all of them. I think Sneh had the next one. And the question was, Mary, you can rewind and watch this. I'm going to do as many questions as we can get done today. The next question was, I believe, about confidence intervals, and let's look at it. The question is, if we have a higher confidence interval, we are less precise because our interval is wider. Increasing the sample size makes it tighter, which lowers the margin of error. Yes, there's some true-false on this, and hopefully I'm covering all that right here. If you look at the equation, we have here p hat plus or minus z star square root p hat q hat over n. Now, if you increase the sample size, let's do this. If you increase the sample size, what happens to the margin of error? Just increasing the sample size, what happens to the margin of error? And I don't think the previous one I did will be on the exam. I don't like algebra ones. 1.645, Paulina, 1.645. Great question. 1.645. If you increase n, it'll decrease the margin of error. That is correct. But then if you were to say, because there's weird ones, they say it in weird ways. It says, given the same confidence level, if you increase the sample size, they say it in weird ways. I'm trying to think of the ones they do. Let's just do increasing the confidence level. And this is what I think you said earlier. If you increase the confidence level, what happens to the interval? And this is the z. If you increase the confidence level, the interval will get wider. And there's some tricky ones that say, like, if you hold, so increasing the confidence level makes the interval wider, because you're going from like a z of 1, 68 to 2, 95, 3, 99.7. No worries, Zach. 10,000 points, Zach and Braden right there. But it'll make it wider. Does a higher confidence interval mean higher margin of error? All things held constant. If you have the same sample size and increase the confidence, the margin of error does get wider. Everything else held constant, higher confidence will increase the margin of error. Does that make sense? Because you'll increase the z. And just mathematically right there, z will make it a wider error. So all things held constant, if you increase the margin, if you increase the confidence level, and if you want to double check, there's some true falses on there, and they weird in interesting ways. If you want to copy one to the chat, I will like try to answer it directly, because some of them are like, holding this constant, what would this do? So hopefully that did it right there. I saw another one. I think it was, Ashton might have asked it. But I think I saw another question. Can we go over the homework question that asked to give a 99% confidence interval? So for a 99, these are true falses on the quiz or the homework. So let's mention a really good thing to mention right here. How do we get these z-scores for the homework? On the test, this is where people might have a few errors. We're going to go to David M. Lane, and what we will do is always carry all your significant digits. So carry all your significant digits as far as you can while working on the problems. And if you do miss it by like a decimal or two, just tell me, as long as it's not like a lot. Just tell me like, hey, Brian, I entered this one in incorrectly. And there are some where I'm like, but then there's other ones like, yeah. Who has emailed me and said, Brian, I'm off by like 0.1 and I gave it back to you? I know I ask you guys this all the time, but I just want people in the chat to be saying, I've done that. See, there we go. There you go. Look at it. I'm shocked there's not more, but I know a lot of people have, and they said, Brian, but probably there's gonna be that one person who says he didn't give me the points back. So if you're off by like a point, I will give it back to you. And do realize I respond to probably sometimes about 100 emails a day. So do realize I do get to every email each day. And so thank you for everyone who knows that, because I appreciate it very much. And let's take a look right here. Let's go right here and go to between. And we go to 95. Oh no, what do we do? What did I just make right here? I know Pearson is craziness. Brian just made a what interval right here? I know it does. I like that, Julio. It's so precise. It really does. You have to be very, very exact. It's mathematics. Oh, totally. Wait. Zach, you are too much, Zach. You are crazy. Why did you do that? So 9.5% confidence. Yes, I was like, I looked at the z-score and I was like, what is going on with that z-score? There it is. There's the correct z-score. I'm confused on the following problem. Numbers on the wheel are between 5 to 100 increments. Use 5. Random numbers generate with the following you get on the first 2 spins. Yes, I think that's one of the ones on the Quizlet that I wrote a while ago. I'm going to have to copy paste that from the chat right here. I don't even know if I can copy paste from the chat. Let me make sure. Okay, let's make sure I'm copy pasting from the chat. I put the links here last. Should be good. There we go. So here we go. This one is a Quizlet problem on randomness. That's interesting how it looks right there. So this is a randomness Quizlet problem. I'm going to deselect. What? What are you doing, computer? What? 2 seconds. And here we... Look at that. That's so nice right there. Okay, numbers on a wheel. Okay. Sorry, my Quizlet problems might be a little bit old, but let's do a randomness problem right here. I know the inverted color is fun. Nice to look at right here. So what do you get on your first 2 spins right here? I made it so long ago. It's linked on the Stats 1 webpage. And when you generate numbers on a wheel, I want us to think about this. This one requires a good bit of thought. So this question right here, when you look at these random numbers, just pause to think about it for a moment. Random numbers on the wheel are going to be between 5 through 100, and we're going to go in increments of 5. So how many would that be? It'd go 5, 10, 15, 20, up to 100. So when we turn these into random numbers, watch this. We'd get 0, 1. Oh, we don't need a space pen on that. It's not looking so awesome there. We'd get 0, 1, 0, 2, 0, 3, and that's the 20th number. So this one right here is we'd have 20 numbers on the wheel, and let's generate these random numbers right here. The random numbers are going to be, the first 2 random numbers is this, and then here, here. Oh, I did so nice on this, because now you can actually separate them. So we'll make it even more separated, make it clear. So what is the first spin on the wheel? Who can tell me for 10,000 points what the first spin on the wheel is? Who can tell me what the first spin on the wheel is? Ah, it's not an 18, it's a 90. Braden, you got it. So this is converting these random numbers into what they actually are. No worries, this is a 90. What is the second spin on the wheel? And notice what you can do to convert these. The second spin on the wheel, look at the pattern right here, and look at the pattern right here, where if it's a 4, it's really 20. So the second spin on the wheel is an 11, but that's really a what? A 55. The next spin on the wheel is really not a 10. It's not a 10, but it's really a what? A 50. So this right here is random spins on the wheel and turning these numbers into actual spins on a Price is Right wheel. So it requires a little bit of like kind of sorting through it. Great question right there in the chat. And I think we're going to go back to the David M. Lane just to show you, and I think hopefully I made it clear. Whenever you're asked to build a certain % confidence interval, you'll go right here, and if it wants 90, you'll put that. Or 98, you'll put this, 99, if it says something like 94. And you notice what happens as I increase my confidence level. The interval gets wider. As I increase my confidence level, the interval gets wider. So that's what we were talking about earlier, is that the wider the interval, or the more confident the interval is, the wider it gets. So all this good stuff right here. Let's make Brad, I'm on the chat right here. So more questions. We tried to cover as much as we can. If we are given questions like, what is the Z for an 80? Oh, we wouldn't do that. That is 1.2818. Not that you should know that. It's called too many of these. 1.2818 doesn't do all the decimals. We'd never ask you what the Z-score is. We will give it to you. What type of random questions, Wheel of Fortune or dice rolling, for example, will be on the test because homework and quizzes were hard ones? I think it's a little bit easier. You just have to think of it as a game. Every time you get to a randomness problem, always think about it as a game. So always think about this is a real simulation right here. We're actually simulating numbers. So let's actually do the full simulation. The more confident an interval is, the less precise it is. Casey, 10,000 points in the chat. The more confident an interval is, the less precise it is. And you can make an interval more precise by making it less confident, But what is another way to make an interval more precise? For, you heard it, 100,000 points. 100,000 points. What is another way to make an interval more precise? You could make it less confident, but what is another way to make an interval more precise? What is another way? Ooh, that would make it less precise. That would make it less precise. Increase sample size right there. Julio, nice answer. Kind of the more trials idea. That is how you make, and think about that. That's how you make a simulation more accurate, is you increase the number of trials, but you could make an interval more precise, like more accurate, by increasing the number of samples. 10,000 all those answers, and Julio got it first. Nice job right there. So we can increase the number of samples to make an interval more precise, and we can increase the number of trials in a simulation to make a simulation more kind of precise, accurate, we say. It's more, I guess, more precise. Different kinds of samples. Great questions. So let's do that. That'll bring us towards the end of class. That's a, new webpage right there. So let's go right here. Go to a new page. We got this. So let's take a look and let's do our sampling methods. So we're going to go zoom out a little bit here. Our sampling methods are as follows. So we've got right here the simple random sample. Yes, is that on the practice test? Because I removed a question from that earlier from the practice test. So I removed a question, but I might need to remove that video on YouTube. That would be chapter 14. It's on the Quizlet. Oh no, I got to change the Quizlet up. This semester we slightly changed what is on exam 2. Sorry about that. That is on test 3. Let me delete that from the Quizlet tonight. Thank you very much. Send me an email reminder. I'm going to give you 10,000 points. I removed it from the test or from the practice test. That is not on this test. Great question, not on this test. So we do, and let me just mention this briefly here. Whirlwind of a class today. Yes, there are. It should be right there on the YouTube channel. If you can find it, email me. But it's also on the Stat 201 webpage. So on the Stat 201 webpage, let's go over to the Stat 201 webpage. And you should go to exams, exam 2. And I need to center those titles, updated them this morning. And here are all the review videos for exam 2. If you go right here, you can see the different videos and lots of videos, lots of help right there on the channel. So check that out. Lots and lots of videos. I'm going to take a vote. We've got like 15 more minutes of class left because I'm going to go a little bit longer today. What does everyone want to do? Because I know we have some videos on the sampling. Let's see votes in the chat right now. What are we going to cover? And we will have more review. So we're going to have lots more review to come. We're just watching Stats 1 in the background right now. What should we cover? Question 5 on the practice exam. There's a vote for that. Homework. I see homework. So we've got homework, practice exam, randomness and probability. There's no consensus. Everything. Anything that's going to be on the test. If you're saying not homework. Probability. I see a lot of I've seen multiple probabilities. I see multiple practice. Okay, we're going to go practice. There's enough practice exams. Okay, we're going to do number 5 on the practice exam. Number 5. So this is probability right here. Let me take a look at the question. Awesome. Okay, this is an excellent one. I think this is a great choice right here. True, false that you think would be helpful. Oh yeah, we'll try to do that next here. So we've got this one. The Kahoot will be tomorrow. I'll send out some email reminders about this. So with this, let's grab this problem and let's bring it over here. There we go. And let's snip this problem. You can get a little bit of the header right there. And let's go over here to a new Word document. And here we are. Okay, a high school student is interested in attending an Ivy League school. As long as has a GPA of 4.0 and SAT score of at least 1,300, there's a 38% chance of getting accepted into any university. So we're going to go right here and we're going to highlight that 38%. The 38% needs to be noted down here, or we'll put it up top, that the probability accepted is equal to 0.38. Now the probability of rejected is equal to what? Who knows the probability of rejected? So we either get rejected or accepted, one of those two things. It's going to be Wednesday. We're going to move everything to Wednesday. So I'll send some updates about that. Sorry for any confusion on that. I've moved it around a few times. We have another test tomorrow night, or yeah, fun stuff this week. So we have here that we have the probability of getting accepted or rejected, and this must equal 100%. This is where people often run into problems with these questions, because from here it gets a little bit more difficult. It says, what is the probability that he is accepted to at least one of these schools? He's going to apply to how many schools? He is applying to, one can assume that it's independent. This is a key word right here, because the multiplication rule. If we have independence, we can multiply. And he's applying to how many schools? Did I miss that part of the question? What is the probability that the student is accepted to at least one of these schools prior to he has met all the things? Where am I missing? The student is applying to Ivy League school. There should be how many schools he applies to. Have I lost my mind? It's 8? Where does it say 8? How am I missing this? Oh, I see it. Wow. There we go. Awesome. Thank you. 10,000 points for everyone saying 8. I just was glancing over that. I can't read. Okay. So this is how we solve these problems. Please take note of this. First, read the problem. That's an important thing. Here is what you need to do. This is Brian's method for solving all of the at least one problems. I hope to see this on many tests. This is how you solve an at least one problem. First off, we're going to draw a number line. We're going to draw 0, 1, 2, 3, 4, 5, 6, 7, 8. We have our number line. Now we have to imagine. So let's talk about what would happen in this scenario right here. I want you to pretend you're applying to 8 Ivy League schools. What does that mean if 0 is the amount that accepted you? What does that mean right there? 0 is the amount that accepted you. I'm basically saying it. What does that mean if 0 is the amount that accepted you? Rejected. Kind of sad right there. You got rejected by 8. So we don't want that. Interestingly enough, what we want is this. Space pen come to the rescue. We want this. We don't want this. The red underline is you were rejected by all 8 schools. Do you see how I'm saying this? You were rejected by all 8 schools. So, Zach, you're the best. So you're rejected by all 8 schools, or what? So either the red happens, which is you're rejected by all 8 schools, or what? Andrew, I agree. So either you're rejected by all 8 schools, or what? You're rejected by all 8 schools, or what? Either you're rejected by all 8 schools, or you weren't rejected. I'll take that right there. You were accepted by at least one. Both of you right there, Kaylee and Dylan, 10,000 points. And also, I think Nicholas is saying it too. And then be careful. It's either you're rejected by all 8 or at least one accepts you. Does everyone see how we've drawn this out right here? That we have the red, whereas you're rejected by all of them, what we don't want to see. And then the 1 and above is that at least one accepts you. Wouldn't you say to your parents, like, either all 8 schools are going to reject me or at least one will accept me? I mean, wouldn't it be awesome? What happens right here? All 8 schools accept you. That'd be great. So we could hope for that. But, I mean, as long as we get into one Ivy League, that's cool. I mean, UT's Ivy League. That's what I'm talking about. So let's go right here and let's talk about this. Because if we think of this as a math equation and we were to add together both of these probabilities, what would we get if we add together the probability of none accepting you or at least one accepting you? What would we get if we add together those probabilities? And I basically said it. Elizabeth, I might not understand the question. I'll double check. And think about this. This is an or one right here because you can add these together because you can say either none will accept me or at least one will accept me because these are disjoint. So when you think about this, this has to equal 1. Now I'm going to do something right here. I'm going to call this x and I'm going to call this y, and x plus y equals 1. Does everyone see what I've done? We just have x plus y equals 1. Now, with most math equations, what do you want to solve for? You could call it Q, you can call it R, you can call it whatever you want. But think about this. You probably want to solve for what right here? This wants to find the probability that at least one school accepts you. And I think Snae's got in the chat. You want to solve for y actually in this one. This is a y solve. So I know, and so we're going to solve for y right here. I think I've done so much statistics that we always solve for y. We always do like y equals this. So we're always like solving for y. We're inputting x and solving for y. So what does y equal? Y equals 1 minus x. And if you look at it, it's either this or this will happen. So they're complements of each other. They're just complements. So y is the complement of x. So now we just have to say what x is. This is the way to do it. I know it seems really long, but we're showing all of our work. We're talking through it. And now all we have to do is say what x is. X means that all 8 schools reject you. How do we find the probability of all 8 schools reject you? What is the probability of all 8 schools rejecting you? Well, this is the probability of 1 school rejecting you. And this is the probability of all 8 schools rejecting you. So that right there that I've written is the probability of 1 school rejecting you, and then, or excuse me, of all 8 schools rejecting you. And I can make it 1 school if I do this. I can make it 4 schools if I do this. But we want 8 schools. So we square this, or not square it, we raise it to 8. And that is the probability that all 8 schools reject you. And this is the probability that not all 8 schools reject you. So that is everything but all 8 schools rejecting you. So 1 minus the probability of all rejected. Because either all will reject you or not all will reject you. And what does not all rejecting you mean? It means at least one accepted you. And practice this. This is the way to solve these. There's many questions we can make up from this. All it is an at least one problem. So it's the complement of, is that the same of Zach? Great question. I'm going to give the last 100,000 election. We're going to hang out a little bit longer here. But the last 100,000, we're hitting that random button so much. I want for someone to explain what Zach found. Someone needs to explain what Zach found. Zach said, what if we were to take this and it were to be different here, and we had something like 1 minus 0.38 to the 8th. So what is that? What would that probability be? That would be this. So 0.38 to the 8th is they all accept you. It'd be everything but all the schools accepting you. So the probability of at least one rejecting you. I don't know if anyone said in the chat. Wait, the probability that at least one school will reject you. Caleb, amazing answer. I think Caleb, you're first to get it. If I didn't see anyone else who got it, just give yourself the points, but great work. This, what I've written now, is the probability that at least one rejects you. Because either they all accept you. Would you agree? Either every school accepts you or at least one rejects you. And when I say or, you can add them together. So that's why we get this x plus y right here, where at least one school accepts you. All schools accept you, or at least one rejects you. We've switched the problem now to what is the probability at least one school rejects you. So either all schools will accept you, or at least one will reject you. So the probability of getting accepted is this. The probability of all 8 accepting you is this. The probability of not all 8 accepting you is this. Does that make sense? Who feels like they understand this a good bit better? I hope that this example right here and solving it this way, practice this, write it down. This is my way to solve these out. See, I feel like, practice. You got it. Take this same problem and then do what I did and watch this. Let's say you play for a baseball team. We're going to use baseball example to end class. Let's say you play for a baseball team, and historically your baseball team wins 70% of their games. In the next 3 games, what's the probability you lose 1 game? So the probability of winning is this. So we're going to say, we're just coming up with another example. Probability of win is equal to 70%, and probability of lose is thus equal to, I don't think you can tie in baseball, but let's say the game has an outcome. So what's the probability in the next 3 games you lose 1 game? So what's the probability in the next 3 games you lose 1 game? Let's do our method. You ready? We're going to write down this. And so we could say we could win all 3 games, which is what we're not interested in, or we could lose at least 1 game. So does everyone see we don't want to find the probability of win all 3 games. We want to find the probability of not winning all 3 games. They won't let me, Abby. They won't let me take the test. So I write the test. So, well, thank you to the people who wrote the test this time. I help review it and I help prepare it. So, you might have the answer. Is that the answer? You've already figured out the answer? This right here is the probability we win all 3 games. And the probability we win all 3 games is going to be 0.70 to the 3rd power. And I think you're right. Well, I can't do the rest of the math in my head. And then this is going to be the other side. This is what we want to solve. And if you look, we can solve it this way here. I'm just putting in what the numbers are below it now. And if you look, you'll look just to solve y, we throw this over here. So that's going to move. Well, this whole thing goes over here. And that becomes a subtract. And there we go. So now what we have is everything but winning all 3 games. Would you agree that we either win all 3 games or we lose at least 1? And this right here is a very quick version of that question. So if you were able to do this question pretty quickly and get the right answer and make sure you read it, this is winning a game. This is winning all 3 games. This is everything but winning all 3 games. Say those words. Say it as you do it. Once again, watch as I do this. This is winning a game. This is winning all 3 games. This is everything, because 1 is everything but winning all 3 games. Does that make sense? I'm going to read it as a sentence. Everything but winning all 3 games. And look at it. Everything but winning all 3 games is this. Just visually, it's everything but winning all 3 games. And I know it sounds weird to say, well, everything but winning all 3 games. That means you lose at least 1 because either you win all 3 games or you don't win all 3 games. And what we've highlighted now is not winning all 3 games. What on my number line does this represent? What does that represent on the number line? It only represents this. That represents that. And as soon as I do 1 minus, it's the other side of it. So the 1 minus is the complement of that. It's the other side of it. No, great job, everyone in the chat. Does this make sense? Who feels like they have a better grasp of this topic? This is my favorite way to do the at least ones. Why do you subtract from 1 earlier problem by it said at least 3? Would you subtract 3? Great question. We will never do on this test an at least 2 problem or an at least 3 problem. It'll always be only an at least 1 problem. So the Huskies have joined the chat. So we'll never do at least 1, at least 2, at least 3. We'll always do at least 1. So we'll never say like, what's the probability of 2? That requires a formula we don't use in this class. There's so many topics we could go deeper into, but we do not do that one in the class. But that's got it. You know what I noticed? Streamlabs has a good Zach, catch the bus. I'm going to head off here. I'll be sending updates, and I'll send updates about the Kahoot. But that's got it. Thank you so much. Everything's going to be all right. We got this. So what are the next videos for Kahoot reviews? Tomorrow we'll be reviewing a lot. I'm going to try to come to the studio at 2 p.m. tomorrow. 2 p.m. I'll be in the studio. So wait for update emails. Every video will be posted. Try to join live. Best way to learn is to be live. So check it out. Can we watch the... Yep, we'll be live. What are the next videos and Kahoot videos? They'll be at 2 and 3:30 tomorrow. 2 and 3:30 tomorrow. Do everyone know that 2 and 3:30 tomorrow? I'll send out some reminders, and that's got it. Any other last few questions? I want to make sure I answer those questions. And thank you so much for those tech issues we had earlier. So I appreciate it, and sorry for the craziness. The note-taking quiz, though, yes, that is in the March 3rd video. I do it at the end of the video. Jacob, check out the March 3rd video. Send me an email if you can't find it. So Rex, send me an email and we will find out a good solution. So Rex, send me an email. We'll find out a great solution. We want to work with all students and we'll find out a great solution. Any other last 2 questions here? Thank you for everyone with all the questions. Awesome, Zach. Everybody, so great. Just to clarify, there's going to be a question based on jump could be in there. Jump could be in there. Some output like decision trees. Definitely decision trees, Kaylee. Which we didn't really cover today. We'll probably do some of that tomorrow during review, but check it out. We've got decision tree videos and up like that. Can't even speak right now, but all that good stuff. That's got it. Email me those questions. I'll be responding later. Talk to everyone. We're going to start with some Stat 201 outro again. Fun stuff. You're welcome, Kaylee.